students, it's Miss Culver again. It is still Thursday, April 29th, and we are still looking at the unit circle, but now we're looking at trig values of special triangles. This was a Khan Academy topic that Stella said she needed help on, and I can bet everyone needs help with this. I really feel bad I'm not in the classroom with you on this because it's really cool, makes a lot of sense, and it's just better done in person. Here is the unit circle here. I am uploading this all filled in to you along with this video and another video that Lucas Schock needed help on, and I'm sure a lot of students do. But right now we're just going to accept the unit circle as it is. Again, next week you will be watching one I do filling this in for 20 minutes because it is amazing. But of course, we have to go see what Kidders is up to now. What's Kidders up to? Just looking beautiful. Hi, Pumpkin. Hi, Pumpkin. Oh my goodness. What a beautiful cat. Look at that. Anyway, again, it is just me. Here I am shooting this video because my cat can't, and Bill and Doug are not here. So I hope I do a good job with this. So let's talk about the unit circle again. I said this in the last video that I posted today, but you may need this. So on the unit circle, notice in red, I have filled in the degree measure and the radian measure that is equivalent to that degree measure all the way around. You did this in Algebra 2, but it doesn't mean that you don't need a refresher or that it's not understandable. In blue around the circle is cosine, sine, and tangent, the values there. Those came from the special right triangles we already did a video on. Notice in the x position, this is like an xy point, and in the x position is cosine for good reason. In the sine position, right, in the, y position is sine for good reason. I spell it all out in my unit circle video next week. And tangent there is actually y divided by x, again, for good reason, but we are going to accept these values as they are, okay? I also want you to know that if you rotate upward from 0 degrees or 0 radians, that would be a positive angle measure. If you rotate downward, that would be a negative angle measure. Notice I also took the unit circle and pretty much laid it on an XY plane. So you can see here that I say where the X's and the Y's are positive and where the X's and the Y's are negative. We're going to need those. Okay, so trig values of special triangles. Here are the notes. You may want to press pause in case it helps you to write this down. Here's what I want you to know. Any right triangle, this is number 1, with the same acute angle will have the same cosine, sine, and tangent value, except with a change in positive or negative depending on the location. So let's take a look at this. Let's say that you have a right triangle with a 30-degree angle in it. Okay, that would mean right here, if I dropped a perpendicular line, that would be a right triangle at 30 degrees. This is in the first quadrant. Notice cosine is the square root of 3 over 2. Notice sine is 1/2, and tangent is the square root of 3 over 3. Let's go to the second quadrant. In the second quadrant, if I go 30 degrees away from the x-axis, notice here, if I dropped a perpendicular line, I would have a 30, 60, 90 degree triangle. So, of course, the trig values would be the same. Let's take a look. Sure enough, cosine is a square root of 3 over 2. Sine is a 1/2. Tangent is a square root of 3 over 3. It's just that cosine is negative because you were in quadrant 2. Sine is still positive because you're in quadrant 2. And of course, tangent is negative because that's y over x, and that's a positive over a negative. Let's go to 30 degrees in the third quadrant. Here we go. 30 degrees, right? We're 30 degrees away from the x-axis in the third quadrant. If I dropped a perpendicular, it would be up to the x-axis. Notice the trig values are the same. The signs are just positive or negative. They're negative here on cosine and sine based on the fact you're in the third quadrant. Tangent is positive because a negative divided by a negative is a positive. And the same happens in the fourth quadrant. You may remember this from Algebra 2. Let's look at number 2. So all trig values are located in quadrant 1 and repeat through quadrant 2 to 4 except with sign changes. So really all you need to know are the trig values in the first quadrant because they repeat in quadrants 2, 3, and 4. They just change sign, positive or negative, based on your location. So here's the actual work they're having you do on Khan Academy. How do you find trig values of angles then on your own that are not in quadrant 1? A, I'm just going to go through this list and we're going to do it 3 times. A, draw a picture of your angle. So we're going to do that first. Once you do that, take a look at it, and what angle are you from the closest x-axis? Use this angle to get the trig value from quadrant 1. So we're not in quadrant 1, but that's where all the values come from. And then I'm just going to check my original angle's location, and will my trig value be positive or negative based on my location, and we'll check on the unit circle. So the first problem we're going to do, and again, I hope this isn't too jumpy, it's just that it's just me. It's just me doing this, and so I'm going to have to kind of go in and out on this. So let's say they ask you for cosine of 5 pi over 4. Now I know what you're thinking. Right here on the unit circle, right there, there's 5 pi over 4. There's cosine, a negative square root of 2 over 2. Why can't I just look at the unit circle and do this myself? Because when you are in calculus, they will ask you for cosine of 5 pi over 4, and you do not have a unit circle in your hand. You're not allowed. It's not on the AP exam or in my class. So how do we get this on our own? So here's what we do. Cosine of 5 pi over 4. I'm going to draw 5 pi over 4. And you may be like, well, I don't know how. You do. Actually, pi over 4, right there, you know, is 45 degrees. Right there. Okay? If you don't know, you will next week after you see my video. And I have 5 of them, right? I have 5 of them. Now, pi over 4 is 45 degrees, so I'm just going to count 5 pi over 4s. Ready? Let's count together. So pi over 4 is 45 degrees. There's 2 in each quadrant. So here we go. I'm going to count. 1 pi over 4, that's 45 degrees. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. There we go. That is a picture of 5 pi over 4. The next thing I do is I say, okay, well, how far am I from the x-axis where I landed when I rotated? Well, I was counting. I went pi over 4 past the x-axis. So that angle right there is called my reference angle. And I know what cosine is of pi over 4. So here's what we do first. Cosine of 5 pi over 4 then is equal to, first of all, let's do cosine of pi over 4. You will have that memorized, but let's look at our unit circle. That is a square root of 2 over 2. Excellent. I have the value. The last thing I do is I go, well, is this positive or negative? Let's look at my location. Cosine are the x's, and based on the fact I'm in the third quadrant, my x's are negative. There we go. That is the my final answer for cosine of 5 pi over 4 is a negative square root of 2 over 2. Let's go over. Let's go to 5 pi over 4. Let's go to cosine. We are correct. Okay, I'm now going to erase because it helps to have a couple examples. Okay, I will bet you could use sine of 2 pi over 3. Sine of 2 pi over 3. Okay, what is the value of sine at the angle measure 2 pi over 3. Let's draw ourselves a picture first. You may say, I don't know how. Yes, you do. There we go, pi over 3. That is 60 degrees. I've got 2 of them. Okay, so I'm going to rotate 120 degrees, or 2 pi over 3s. Ready? Here's 160 degrees. Here's another 60, that's 120. There we go. Here is my location. This is 2 pi over 3, or 120 degrees. Now notice that I am 60 degrees short right there. How far am I from the x-axis? I am 60 degrees short. I'm going to call that pi over 3. What does that mean? That means I am going to get the value of sine at pi over 3 from the first quadrant. So let's go ahead and do that. So you will have this memorized later. So sine of 2 pi over 3, first of all, is equal to sine of pi over 3 in the first quadrant, right? That is the square root of 3 over 2. You will have that memorized. Excellent. Now I just have to check my location. Let's see. I am in the second quadrant. Sine is associated with the y values, and sine is positive in the second quadrant. What does that mean? Here's my answer. I keep it positive. Let's go check. Let's go to 2 pi over 3. Here we go. Let's check the sign. We are right. The square root of 3 over 2. Let's do one more. Let's do a tangent of 330 degrees. Tangent of 330 degrees. All right, let's draw that first. Now, there's a couple ways to draw this. I could just simply rotate 330, but you know what? That's super close to 360. So 330 must be all the way around. I am just short 30 degrees, right? So how far am I from the x-axis? Well, I'm short 30 degrees. Okay, what does this mean I do? That means that I'm going to find tangent in the first quadrant of 30 degrees. You will have that memorized. I know it's the square root of 3 over 3. You'll see great ways to memorize these. Okay, now let's see. Is my tangent, though, going to be positive or negative? Notice I'm in the fourth quadrant. Back here we said that tangent is actually y over x. There we go. Let me take a look. In the fourth quadrant, y is negative and x is positive. So a negative divided by a positive is a negative. Here's my final answer. Tangent of 330 degrees is a negative square root of 3 over 3. Let's go look. 330 degrees, right? And here is our tangent. We are correct. So I hope this helps. There's a really nice step-by-step process to take here to answer these questions. And I really feel that next week when we do the unit circle video, filling it in, that you'll really, even though you saw it in Algebra 2, it'll really all come together for you. There you go. Have a great day.